Namaste to everyone. I welcome you all in my YouTube video channel. Today I will deliver lecture on ring theory, lecture number 8, in which I will solve some more problems on units of a ring. Now we solve a problem. Problem is, in a ring Zn with binary operation addition and multiplication, so that an element m bar is a unit if and only if the GCD of m and n equal to 1. Before solving this problem, I would like to give some basic concepts that what is Zn, what is the value of multiplication of two elements of Zn. By a particular example, firstly I will try to give this concept. We have Z6. What is Z6? If we divide any integer by 6, we get remainders either 0 or 1 or 2 or 3 or 4 or 5. Now we collect all those integers such that if they are divided by 6, they will give the remainder 0. These integers are 0, 6, 12 and so on. We call this set by the symbol 0 bar. Similarly, 1 bar means a set containing elements 1, 7, 13, 19 and so on. If we divide any integer 19 by 6, 6 3s are 18, remainder 1. And in this way we get the elements of Z6 as 0 bar, 1 bar, 2 bar, 3 bar, 4 bar, 5 bar. Now we multiply two elements. 2 bar multiply 1 bar. This is 2 bar. 2 multiply 1, 2 bar. 2 bar multiply 3 bar. That is 6 bar. 6 bar means if we divide 6 by 6, then we get remainder 0. So this is 0 bar. If we multiply 3 bar multiply 4 bar, this is 12 bar. Since 12 bar is not element of Z6 here directly, so we divide 12 by 6, then we get remainder 0. This is 0 bar. If we multiply 4 bar by 5 bar, means 20 bar. Here 20 bar is not element of Z6. So we divide 20 by 6, we get remainder 2. And result is 2 bar. This 2 bar is an element of Z6. So in this way we may multiply two elements of Z6. In the similar manner, we get elements of Zn 0 bar, 1 bar, 2 bar, n minus 1 bar. And similar to Z6, we may multiply two elements of Zn. Now we solve our problem. Here let m bar be a unit in Zn. Therefore, there exists an element u bar belongs to Zn such that m bar multiply u bar equal to 1 bar, unity of Zn. This means when m multiply u is divided by n, we get remainder 1. Therefore, n divides mu minus 1 implies that mu minus 1 is equal to n multiply an integer v. V belongs to Z by division algorithm. Implies that mu minus nv equal to 1, implies that mu plus n minus v equal to 1, minus v belongs to Z. Implies that this means GCD of m and n is 1. GCD of m and n equal to 1. So this part proved. Conversely, let GCD of m and n equal to 1. Therefore, there exists x, y belong to z, z be the set of integers. We get mx plus ny equal to 1. Implies that minus ny equal to mx minus 1. Implies that n multiply minus y equal to mx minus 1. Minus y belongs to z. Implies that n divides mx minus 1. Means when mx is divided by n, it leaves remainder 1. That is, mx is congruent to 1 modulo n. This is number 1. Let x is congruent to r modulo n. Means when x is divided by n, it leaves remainder r. Implies that mx is congruent to mr modulo n, since GCD of m and n equal to 1. Only for this reason we are able to multiply m in both sides. Implies that mr is congruent to mx modulo n. This is number 2. From 2 and 1. Here mr is congruent to mx modulo n, and here mx is congruent to 1 modulo n, means mr is congruent to 1 modulo n. That means m bar r bar equal to 1 bar. Means when mr is divided by n, it leaves remainder. That means the product of m bar and r bar, m bar and r bar are elements of Zn, and their product will be equal to 1 bar. Implies that R be the multiplicative inverse of m bar. Therefore, m bar is a unit. Proved. Now we solve the next problem. Next problem is, let R be a finite ring having no divisor of 0, then each non-zero element is a unit. Now we have to solve this. Since given that R be a finite ring and let it has n plus 1 elements, a0, a1, a2, an, in which a0 is the zero element. Also, R contains no divisor of 0. We know that a finite ring having no divisor of 0 must contain unity I. Now let us consider the products a0 multiply a1, a1 multiply a1, a2 multiply a1, an multiply a1. Since by closure law all these products are elements of ring R, and a0 multiply a1 is the zero element. Since a0 be the zero element multiply an element is zero element. We may write this as a0 or 0. Also, R contains no divisor of 0. Therefore, product of two non-zero elements may not be zero element. So, a1 multiply a1, a2 multiply a1, an multiply a1 are non-zero elements of R. If possible, let ai multiply a1 equal to aj multiply a1, implies that ai minus aj multiply a1 equal to zero element. Since a1 is non-zero element, so this part will be zero element, implies that ai minus aj equal to 0 element implies that AI equal to AJ. Therefore, A1 multiply A1, A1, A2 multiply A1, dot 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 AN multiply A1 are all in distinct elements of ring R. Among these, one of the products will be unity I. Since this ring contains unity, let AP multiply A1 equal to unity I. Let this is number 1. Similarly, by taking products A1 multiply A0, A1 multiply A1, A1 multiply A2, dot 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 dot, A1 multiply AN, we may show that A1 multiply AQ equal to unity. This is number 2. Now, AP multiply A1 multiply AQ equal to, by associative law, AP multiply A1 multiply AQ implies that this is unity I multiply AQ, this is AP multiply, this is unity from 2 using 1 and 2. Implies that AQ equal to AP. Let this is number 3. Therefore, from 1, 2 and 3, we get AP multiply A1 equal to, here we write AP in place of AQ. A1 multiply AP equal to unity. Therefore, A1 is a unit, means we get the multiplicative inverse of A1, that is AP. Similarly, we may show that each non-zero element of R is a unit. Proved. Now we have an important note. Note is, if a ring contains infinite number of elements having no divisor of 0, then each non-zero element need not be a unit. By an example, we may show this. Example is the ring Z with binary operation addition and multiplication contains no divisor of 0, but each non-zero element is not a unit. Since 1 belongs to Z, Z contains infinite number of elements. 1 multiply 1 equal to 1, unity, 1 be the unity. Therefore, 1 is a unit. Minus 1 multiply minus 1 equal to unity. Therefore, minus 1 is a unit. 5 multiply 1 by 5 is 1, but 1 by 5 does not belong to Z. So 5 is a non-zero element, but 5 is not a unit. Similarly, other non-zero members of Z will not be unit. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button and do subscribe my YouTube channel. Thank you.